Hola, 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 buenos días. ¿Qué tal? Good morning. Bonjour.
¿Crees que lo podremos dejar encendido o te molestará mucho?
Yo creo que encendido, ¿verdad? A mí no me molesta, pero creo que mejor, ¿no? ¿No queréis que apaguemos todo? Que hace 30 grados fuera. ¿Qué os parece? ¿Qué os parece? Vale. Estoy haciendo un poco el tonto, pero bueno. Ta, 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 ta. Ya está, ¿no? Vale.
Well, welcome everybody to the Sala d'Actes, I don't know how to say that in English, of the Catalan Institute for Water Research, where you know that the defense of a doctoral thesis from the PhD program in Water Science and Technology at the University of Girona will be held today. It's my pleasure to introduce the candidate, Esther Mendoza, who will be presenting her thesis titled Greywater Reuse, Decentralized Treatment with Forward Osmosis and Hydroponic Systems. And the research has been supervised by 3 good friends and excellent researchers, Kim Comas, Gigi Buttiglieri, and Gaëtan Blandin. If you see, there are as many supervisors as members of the jury. Yeah, so that will be like a big battle. Yeah, well, before we begin, I would like to remind everyone the rules. It's not very strict, the PhD program at the University of Girona, but the candidate has like approximately like 1 hour. If it's shorter, it will be much better. But there's not a limit, so you can spend 2 hours if you want to. But I told you we will spend as long as you. So the longer you do it, it will be the same for us. Let me also introduce you the members of the committee. So we have Julie Menderet, Associate Professor at University of Montpellier at the EIM, or European Institute of Membrane in France. Her research activities deal with membrane processes for wastewater reuse, but she recently has been working on PFAS removal. I think that at ICRA you are also good experts on that, but for drinking water production in her case. And as far as I remember, you were also interested in science communication, what I like a lot. And then we have Darija Stenic, Assistant Professor at the University of Ljubljana in Slovenia. She's a biologist with research expertise in nature-based solutions for wastewater treatment and recovery, including green walls for greywater treatment and environmental risk related to reuse of waste streams. So as you can see, her expertise really fits on your topic. I'm the last member, I'm the president of the committee, Ignasi Rodriguez Roda, if you don't know me. I'm professor at the Chemical Engineering Department at the University of Girona. I was 11 years here at ICRA, so for me it's a pleasure to come back. When I came here, I was young and motivated. When I left, I was old, bald, tired, but I enjoyed a lot. So really, it's a pleasure to be here today. So finishing with the rules, you know that after the discussion, the tribunal will stay in this room to deliberate. We have, like, as I told you, a few questions, or we can go to that room. Maybe it will be much better. And the final grade will be announced here. In case that the grade is excellent, and I tell you now because sometimes at the end there's like a confusion with that. In case that we give you the maximum grade, which is excellent, then there's like a secret vote where we can award the cum laude. But you will not know it today. It will be known in a few days. So with further ado, let's start the defense. Esther, please take the time that you need and enjoy, because this is the last stage of your doctoral studies career. So the floor is yours. We will sit down there. Yeah.
Claro. I have to do this, sorry. Yeah, because it doesn't fit. Okay, let's go. Thank you so much. Muchas gracias a todo el mundo por venir. And the presentation will follow the typical structure of a regular presentation. So we start with this drop of raw grey water at the beginning, and then we continue going through the presentation and until we have the treated water in the conclusions. Since this thesis was done as a compendium of articles, I published 5 articles as first author, so in the results I will show you the main outcomes of these 5 papers. Let's start. So over 2 billion people currently face water scarcity. The quality and the availability of the freshwater resources is at risk because of climate change, population growth, and the not proper water management practices. And actually, there are sensitive areas, as the Mediterranean area, where we are now, where they are in risk of desertification, as you see here in the map. And then, no, I'm going to put here, sorry. And then also, some of these areas are reliant on tourism. So the touristic activities play a fundamental role in the economies of these areas. And actually, tourism is known as a water-consuming sector. And also, we have to take into account that the tourists arrive when it rains less in summer. So all of these really put pressure on the water resources. So we need, in general, but particularly in tourism, to go through another model. So we need to go circular. Circular economy is this regenerative model of production and consumption, where we have the products as long as possible in the chain, trying to generate the minimum waste and also to take the minimum natural resources. And actually, the European Union has published in 2021 the Circular Economy Action Plan, which is this future-oriented agenda that has some points to encourage the member states to go circular. Within this paradigm, wastewater is not a waste anymore, but a resource of reclaimed water and also nutrients, because from wastewater we can get, for example, heavy metals or fertilizers. Among the different solutions or ideas to reuse water, I focus on greywater because it's the main fraction of domestic greywater, and also in tourism, for example, in hotels, there are big amount of greywater, so it has a great potential for reusing. Actually, this water, which is the domestic fraction, excluding the toilet waste, is considered as low-strength wastewater, and even like the 60% of this grey water is coming from the showers and the bath, which is the grey water that I was working with, which is called the light grey water. And yeah, this is even less polluted. So we could harvest this grey water, treat it in the place where it's produced, and then reuse it. The most common uses for this reclaimed grey water in domestic applications are toilet flushing, but also irrigation, for example, of green areas that we have, our garden. But of course, there are some safety concerns regarding the reuse of water. The biggest concern is that related to the exposure to pathogens, and this is well known, and is also contemplated, is included in the legislation, but we have other types of contamination. We have physical contamination and chemical pollution. And within the chemical contamination, we have, most of us, we are working with them, so we have these emerging contaminants, the organic micropollutants, that are this heterogeneous group of a lot of compounds that even if they are present in very low concentrations, they are a lot, and they are not properly removed in the conventional treatment plants. So basically, they end up everywhere. We find them in lakes, in rivers, in the sea, in the clouds. So we really need to pay attention to these compounds, and actually a recent review identified 350 organic micropollutants in different greywater sources. So how are we going to treat the greywater in order to have this safe reuse regarding these compounds and in general? In the thesis, I focused in two different approaches through two different technologies. So the first one is an intensive technology. Intensive technologies are great technologies that produce effluents of very good quality. And yeah, going to the membranes, micro, nano, ultrafiltration, reverse osmosis are technologies that are widely applied. They have very good performance. So yeah, we can continue treating this water for reusing. But in my case, I'm focusing in forward osmosis, which is a technology with a high potential, but is not that famous, that much developed. So in forward osmosis, we have two solutions separated by a semi-permeable membrane, very dense semi-permeable membrane. And in my case, the feed solution has low salinity, and I'm working with this grey water, and the draw solution has high salinity. Usually the draw solution is sodium chloride because of seawater. So we have this different in osmotic pressures. In salinity creates an osmotic gradient, which is the driving force of the process. So naturally, the water will flow from the solution with lower salt concentration to the solution with higher salinity. So, because this osmotic pressure is the driving force of the process, we don't need to apply hydraulic pressure, as it happens, for example, with reverse osmosis. In this case, the process is supposed to be more energy efficient, and also the fouling behavior is different. Reverse osmosis has usually irreversible fouling, but the others is like more difficult to cope with. As nothing is perfect, we have also some reverse solute fluxes from the draw solution to the feed solution, which are like negative for the process, because they would raise the osmotic potential, the osmotic pressure in the feed solution, so the water flux will decline. So they are an issue of concern in forward osmosis application. And also we have fluxes from the feed solution to the draw solution. So within this setup, we would have a concentrated feed solution, and from there it's easier to recover nutrients and also maybe to produce biogas. But if instead of using sodium chloride, we use fertilizers as draw agents, then the diluted draw solution can be applied for irrigation purposes. So in this case, we can use the feed solution for recovering or whatever, but the draw solution is also, we can use it. And this approach, which is the approach that I'm focusing in my thesis, is more energy efficient and more economically efficient, because we avoid the need of recovering the draw solution, and also we can use the draw solution with the seawater. We will throw it back, for example. If we flip the coin, we have the extensive greywater treatment technologies. Extensive technologies do not produce that good quality, but they produce effluents of reuse quality, although they require disinfection. But in these technologies, the water treatment is carried out through a synergetic effect of the different parts that are in the system. So these systems usually include plants, they include substrates and microorganisms, so the contaminants are removed through different mechanisms. Examples of nature-based solutions are, for example, constructed wetlands or green roofs that are widely applied. And in my case, I'm focusing on hydroponics, because hydroponics is also a food growing technique, let's say, where the plants, the roots of the plants are in direct contact with the water. And there's no soil there. There is an inner substrate that gives the structure, the mechanical support to the plant. This technique produces higher yields with faster plant growth. The water consumption is lower because they make a more efficient use of water and nutrients. And also we eliminate the risk of pesticides and nutrient runoff that contaminate, for example, the aquifers. So these systems are a great idea for urban agriculture and to increase food safety. So there are some studies, not that many, but I was wondering what is this dual capacity. So since these systems, they are able to produce food, but also systems with plants are able to treat water, why don't we combine both of them? Within this, the general objective of this thesis was to explore the feasibility of the decentralized greywater treatment using forward osmosis and hydroponic systems, focused on ensuring safety. This general objective was carried out with 3 objectives. So the first one was to examine the water management practices in hotels. This is a little bit different. This was developed in the first article. It's a little bit different from the others because it's not like I didn't do it in the lab. It's a questionnaire. I will show you later. But this opens a scenario for the application of these decentralized treatments. Then the second objective was to assess the performance of forward osmosis for greywater treatment and reuse as means of. In the article 2, I was interested on the potential of this fertilizer-driven forward osmosis to achieve the proper fertilizer dilution close to osmotic equilibriums, because we were interested on going to the process until like the limit, so to see what were the capacities. The next, I was interested on testing the capability of recovered magnesium phosphate salts as draw agents in forward osmosis, and then the application of this diluted solution for hydroponics. And then the third sub-objective was to more study the fate and behavior of organic micropollutants during forward osmosis treatment. The third objective was about evaluating the potential of hydroponic systems to integrate both greywater treatment and edible crop production. And it was related to the impact of greywater in the plants and also the pathway of the organic micropollutants from the source, so from the greywater, until reaching the edible parts of the crops. And these two objectives were developed under the fifth article. For forward osmosis, this is the module that I've been using. It's a commercial hollow fiber module from Aquaporin, and from their website I got these pictures. So basically every hollow fiber consists of a support layer that is negatively charged, and then this support layer is coated with an active layer that has aquaporin proteins, that we also have aquaporin proteins in our cells, that are 100% selective to water molecules. About the experimental setup, for papers 2 and 4, it was pretty the same. So I started with 60 liters of feed solution and 2 liters of draw solution. The process was recirculating until achieving the 50% of feed recovery, which means 30 liters from the feed going to dilute the draw solution. So with this, we reached 16 times draw solution dilution. Then the third paper, although the target was the same, we did it in 2 steps. In this case, a smaller module was used, and the first dilution was carried out until having 5 liters of draw, and then we took half a liter from here and continued diluting until reaching or being close to osmotic equilibrium, which was evaluated with a conductivity meter. So as feed solutions, in the 3 experiments, I tested the ionized water, and then in the first paper, and the ammonium hydrogen phosphate, separated and blended with different concentrations. In the next paper, I used these 2 fertilizers combined, and also I compared with sodium chloride, which is, as I told you, the typical draw solution. And in the third paper, the fertilizers, these salts I will show you later the composition, these fertilizers were obtained from wastewater streams, and they were dissolved either with nitric or citric acid. Going to the hydroponic systems that we have here in ICRA installed, this is the system that I was working with. It has PVC canals with the capacity up to 8 plants per canal. So I bought the lettuces in a local store, and I rinsed them until removing all soil particles, and I put them in these buckets with light expanded clay aggregates, which is an inner substrate that provides this mechanical support, but also can absorb contaminants. Then there were LED lights, full spectrum, and then what you see hung there in these like little swings are the sensors of relative humidity and temperature, and they were taking measurements every 30 minutes. For both papers in which I was working with hydroponics, both experiments were lasting 4 weeks. And the plants were exposed to 14 hours of light. The temperature and the humidity were pretty constant. And then for paper 3, I did 2 experimental cycles. So in the first experimental cycle, I tested hazenite, either dissolved with nitric acid or supplemented with nutrients. And in the second experimental cycle, I tested the 3 salts supplemented with nutrients and dissolved in nitric acid. For the paper 5, I was more focused on the organic micropollutants and the greywater. So the difference between the 3 conditions are the nutrients that were included in the greywater. So greywater B is the baseline condition, and it has only like a little bit of nutrients that are commonly present in greywater. For greywater S, I added strobite, and for greywater N, I added the commercial nutrient solution for hydroponics that was also included in the controls that were applied in all experimental cycles, in all the tests. Regarding the synthetic greywater recipe, I used a pretty simple one, but widely used. It was almost the same for the 2 papers in which I used synthetic greywater. I avoid some compounds in forward osmosis because they were present in the other side of the membrane, or they will clog too much the membrane. And then this is the list of organic micropollutants that I chose. Most of the organic micropollutants are pharmaceuticals. except for bisphenol A and methylparaben, which are endocrine disruptors, and caffeine, stimulant, we all know caffeine. And yeah, I choose a mix of organic micropollutants that are commonly present in grey water and that have different physical chemical properties to see whether the behavior of these compounds was also influenced by these properties. I took some samples along this PhD and they were analyzed here at ICRA. I analyzed, depending on the article, different standard. And then at the beginning and at the end of each experiment, the lettuces were like some representative plants of each condition were separated into roots and leaves. The leaf area was measured, and then the fresh and the dry mass was also measured to elaborate different plant health indicators. Today I will show you only the relative growth ratio. Then for the last paper, also the organic micropollutants were analyzed in the leaves of the lettuces. And within this, we did a human health risk assessment, taking into account that an average European adult will eat 50 grams of these fresh lettuces that were grown in this grey water. And for the risk assessment, two indicators were obtained. So the first one, the hazard quotient, was the exposure to each organic micropollutant, and then the sum of all the quotients would give us the hazard index to see the risk of cumulative exposure. Let's go to the results. The first paper was published in International Journal of Water Resources and Development, and the objective was to assess the current water management practices and potential for improvements in coastal hotels of the Euro-Mediterranean region. So a questionnaire containing 72 questions was elaborated. The content of the questionnaire was mainly related with everything that was related to water in the hotels, so presence of pools or supply, monitoring, water reuse, everything. This hotel was sent via mail, and some people were also contacted through telephone to all hotels in the Euro-Mediterranean region, including Turkey, that were located within 1 kilometer from the coast. And it was sent to general managers or owners of the hotels. From these 5,000 hotels, we obtained 113 answers. We only took 80 because we didn't have enough information for the 113. So as you see, it's a very low response rate. It's like less than 2%, but there are no many papers considering that high amount of responses and also studying this, and then that these groups were heterogeneous within them. So 5 clusters were obtained, and here you see the distribution of the countries in the different clusters. So kind of all countries were present in all the clusters. So we see that the characteristics of the hotel are not related with some specific normatives of the countries or something like that. And just clusters 2 and 5 were big hotels. Cluster 1 was the smallest, and clusters 3 and 4 were medium hotels with different, the difference between them was the number of pools and the certifications. Going to the main results, I don't think anyone would be surprised by this. So the main source of water was, of course, municipal water. Whenever alternative sources were applied, were always, of course, in combination with municipal water. Regarding the water-saving devices, if we discard those that didn't answer the question, the majority of hotels had some installation of water-saving devices, and the most common was the dual flush toilet. Grey black water separation was carried out by only 18% of the answers, and only 3 hotels were reported to reuse the grey water, mainly in cluster 2, so big hotels with more economic capacity. The pool or spa disinfection was mainly carried out by chlorine, and the monitoring, like more than the half of the hotels were monitoring, but only 6% were monitoring the different facilities. And okay, we saw that when having certifications, they were more open to share information, which is something good. So from these results, we see, well, I saw many gaps for improvement, because of course, alternative sources of water, they should be used in hotels, at least collected the rainwater and the condensation, you know, from the air conditioner, at least that. And also, of course, greywater in hotels is produced in a high quantity, so it's advisable to reuse. Also, the disinfection methods should be a little more sustainable and less dangerous. And if monitoring, like more detailed monitoring, the water management is supposed to be more efficient. The water infrastructure improvements was only carried out by a quarter of the respondents, and they say that they didn't want to improve their infrastructure, not because they don't see it's a good idea, but because there was not enough money. Going to the second paper, in this case, the main objective was to explore the performance of forward osmosis process at conditions close to osmotic equilibrium and the capability of fertilizer-drum forward osmosis to achieve this effective draw dilution for hydroponics. In previous studies, they always point out that, okay, they achieve some dilution of the draw solution, but they always say further dilution is required to apply for hydroponics. So we say, okay, I think we can reach this dilution within one step. These are the results, like about the general process performance. There you have the different mixes that I tested, the initial concentration in the draw solution and the water fluxes. The water fluxes at the beginning were good, but as you see here, they decrease, the water flux decrease sharply, and it decreased as far as the draw dilution was increasing, of course, because the osmotic potential was getting lower. Going to the concentrations of the nutrients for hydroponics, here you see the final concentrations that I obtained and also the ideal ratio for hydroponics. And well, it is possible to achieve these concentrations, at least with mix 5 for all the nutrients, but for others we're pretty close, so it would be okay to apply this solution for hydroponics. But let's see why this happened. So this is a figure of the reversal fluxes, so the movement of fertilizers from the draw solution to the feed solution when we had either the ionized water or different salts in the feed solution. So as you see here, the reverse fluxes of phosphate are minimal, but when we go to the other ions, they are higher. The highest are for ammonium, and when we had sodium in the feed solution, we had higher fluxes. Going to the other side, so the ions that were in the feed solution going to the draw solution, we see minimal fluxes, but sodium fluxes were a little bigger, and they are very similar in value than those of ammonium. Going to the end, to the distribution of these salts in the feed and in the draw solution at the end of the experiments, well, what you see in the first figure, phosphate, it would be the ideal situation, what I was expecting to find with this technology. So almost or all the phosphate that I included in the beginning in the draw solution remained in the end. It was just the solution was diluted. But then if we go to the others, the results are not very good. If you see, when we had, for example, sodium sulfate, like 75% of the ammonium went to the feed solution. These are not good results for this technology because it means that the fertilizers are losing, are migrating to the other side. And you see that for potassium and ammonium, the results are similar. For nitrate, they are a little bit bigger, and for phosphate are very good. So yes, we reached the dilution, but with a very high cost because we lost a lot of the fertilizers. I'm going to explain you what happened here. So this is like, we can have the feed and the draw solution in a different, located differently, but the explanation would be similar. So what are the rejection mechanisms of the forward osmosis membrane, or the membranes in general. So when the molecular weight, the hydrated size of the compound is bigger than the molecular weight cutoff of the membrane, which gives us an idea of the porous size, the compound doesn't fit and it gets rejected. So the phosphate didn't fit, no? It got rejected. When the compound is negative, also the phosphate is negative, it gets also rejected because this support layer is negatively charged. But when the compound is positive, it gets attracted to the membrane, and the more hydrophobic, the more that it can be retained into the membrane. And then it can experience diffusion, retarded diffusion to the other side of the membrane. But since the system tends to equilibrate, we have also diffusion of the anions. That's why we had higher fluxes of nitrate, because it had to cope with the positive charges of both the ammonium and the potassium. Also, when we have salts in the different sides of the membrane, these fluxes are usually higher, and this is what we saw when having sodium. And actually, some ions that are similar, they can exchange. That's why the fluxes of sodium and ammonium were super similar, because they were most likely exchanging. When we have neutral compounds, usually the interactions with the membrane are smaller, so are weaker, so then they can diffuse easier. So at this point, I wonder what is the efficiency of this process. I believe in the potential, but we had very high fluxes of monovalent ions, that means nutrient losses, and actually when I analyzed the sodium in the draw solution, it was above the level of toxicity. So applying this solution for irrigation would not be very nice for the plants. So we need to improve this performance. Then the third paper, the objective was to assess the capability of magnesium phosphate products recovered from wastewater streams. One was recovered from a domestic wastewater treatment plant, and the others were recovered from a farm. And yeah, to test this, the potential of these fertilizers as draw agents, and also then the application in hydroponics. Going to the forward osmosis performance, there you have the compositions of the different salts and the different acids. So in this case, the water fluxes were much lower, because yeah, the osmotic gradient at the end wasn't that high. And then going to the ion migration, we see different behaviors. Of course, when we have monovalent ions, they would migrate more to the other side. For example, for hasenite, okay, sodium is migrating, but in this case it's good news, because we don't want to have sodium. But for the others, it's bad news. And when we have like bigger anions or cations, so with magnesium and phosphate, they don't migrate that much to the membrane. Going to the diluted draw solution, in this case, again, we reach a proper concentration of, in most of the cases, for magnesium and phosphate. So these are very good news, because this fertilizer was the only source of these two salts. And actually, phosphate is a really critical material, so it's very nice that we can obtain it like from wastewater. And yeah, the others, they didn't reach the proper concentration, because there weren't that much of these ions there. Going to the results of the lettuces, so in the first experimental cycle with hasenite, you see difference between the dissolution with citric acid, so the C or the nitric acid. The nitric acid look better because it has nitrate, so it's food for the plants. So then in the next experimental cycle, we supplemented with potassium nitrate and micronutrients, and here you see that the lettuces look very nice. And actually, when we go to the comparing the different ratios, different size, we see that the four lettuces grew very similarly, like also compared to the control. So these were very good results, because these fertilizers work the same way, let's say, as the commercial nutrient solution. The fourth paper was about evaluating the potential of forward osmosis for greywater treatment and reuse by analyzing these different solute fluxes and the behavior of organic micropollutants. As a general process performance, in this case, we have different water fluxes and operation times, but they are if we compare the two feed solutions, but when we compare the different draw solutions, the performance were super similar. So yeah, we can use fertilizers in the same way that we were using sodium chloride. The reversal fluxes were in general similar, regardless the feed solution. And then going to the rejection of the greywater constituents, of course, sodium was not well rejected, but sulfate and total organic carbon were very well rejected. So for the greywater treatment, that's very, very nice. Going to the rejection of the organic micropollutants, I sampled after 10 minutes and 1 hour and at the end of the experiment and at the end of the tests. And the average of all the samples was above 99%, so these are very good results. The membrane was working very well. The average organic micropollutant concentration in the draw solution was around 1 microgram per liter, and not all of them were found actually. So I assume that applying then this dilution for irrigation would be safe regarding the organic micropollutants. Almost no transformation products were detected, so there was no degradation, or we assume there was no degradation. And regarding the rejection of organic micropollutants, here you have a little more detail. We have some difference between the different tested conditions. Again, we see more difference between feed solution than between draw solutions, because yeah, feed solution when having greywater, it has salts, so we had lower fluxes and it can induce to the movement of the organic micropollutants to the other side of the membrane. But also because when we were having greywater, you see that the experiment lasted like the double of the time, like 14 hours. So the solutions were recirculating like longer time, so this retarded diffusion was happening. This is what I think. And actually, this is the most important result of this paper, although I only have 3 points, so I cannot drive that solid conclusions about this. And although the rejection of organic micropollutants was super high, at the end of the experiment, you see that it decreased. And actually, when I calculated the organic micropollutants in the permate, well, in this case, the increase of the organic micropollutants was linear. With 3 points, I cannot say, yeah, this would keep linear, but it was sure that this concentration of organic micropollutants was rising in the draw solution. So for now, it would be okay because the rejection was very high, but if we continue diluting and diluting until like maybe osmotic equilibrium, maybe we would see more organic micropollutants, and this might raise concerns for this safety of water reuse. Just to show you the rejection of individual micropollutants at the end of the experiment, you see that they are very high in all cases, above 85 and usually about 90%. So it was good. Although I didn't find any linear relation with the organic micropollutants properties and the rejection. There are some trends. As you see, the rejection of negative compounds is a little bigger because the membrane is negative, so they get rejected. And also, usually the bigger the mass of the compound, the bigger the rejection. Going to the last paper, in this case, the objective was to evaluate the capability of hydroponic systems to integrate this greywater treatment and lettuce production and delineate this pathway of the organic micropollutants. Here you see a picture of a representative lettuce at the end of the experiments, and yeah, they are all green. Nobody died, so these are good results. The greywater is not that bad, but there are different trends. And actually, when we look at the lettuces, those ones that were growing with the same nutrient solution, regardless if they were with greywater or with the ionized water, they look very similar. A little bit different in the roots, but they look really similar. And when we go to this, to the to these figures of the growing and the health assessment, we see these two trends. So whenever there was not enough nutrients, the lettuces were a little not very good. And when there was enough nutrient supplementations, there were some difference with the control, but they look good. So from here we can say, okay, Greywater is a proper source to grow plants, and in real applications this water would be treated or pre-treated, so it would be even less maybe complicated atmosphere. Going to the performance of the treatment performance of the system, even if it's a very, very simple system, it didn't have that much absorption capacity, the plants were not very good, very big. You see that the removals of BOD and solids were pretty high, and actually, if we go to the effluent concentrations, we see that the effluent of the condition with more developed plants would comply with the reuse legislation for Europe. And in this case, even if the plants were not that big, as I said, we see that the plants do something, because the other conditions didn't comply, but in this case they comply. So more developed roots, bigger plants, they have something to do in the treatment, even if usually the most part of the treatment is carried out in the substrate. Going to the organic micropollutant removal, in this case, we obtain all ranges of removal. So the removals were medium, and this should be improved. But again, when we had the plants, like the more developed plants, we had a little bit higher removals. And going to the individual organic micropollutants, well, again, I didn't find any linear trend, but yeah, you see that there are more or less removal regarding some of the properties. So in this case, out of these compounds that were analyzed in the leaves, half of them were detected. So only like the half of the compounds reached the leaves of the lettuce. That's not bad news, let's say. And actually, and also 2 of the transformation products of these pharmaceuticals were also detected in the leaves. So what happened here? Where similarly to the membranes, when the compound is small, they can fit into the roots. Also, usually positive and neutral compounds, this is what we detected in the leaves, have higher propensity to reach the edible parts or other parts of the plants to translocate, because the roots are negatively charged. So it's more difficult for them to enter. And then we saw the most pronounced differences for hydrophobic compounds, because usually hydrophobic compounds get retained into the roots. And for example, for diclofenac, we had higher removal in the condition with more developed plants, but then it was not detected in the leaves. So I assume that it was in the roots. So really the roots play a good role here. And then something that we didn't see that much degradation, or the TPs were not found in the liquid samples, but they were found in the leaves. And actually, carbamazepine, it's commonly found in plants, but in our case, it wasn't detected, but epoxy carbamazepine was detected, which means that the carbamazepine was transforming within the leaves. Which are the consequences of this? Well, here you see the different hazard quotients of the individual pollutants. From here we have good news and bad news. The good news are that the half of the compounds were detected, and out of this half of the compounds detected, only 2 would pose a potential risk. Also, we have to take into account that the concentration of organic micropollutants that I was spiking was bigger than in real, a little bigger than in real water. So I assume that the risk would be lower in real circumstances, but also there are more micropollutants in real circumstances. So the individual exposure would not be risky maybe, but the cumulative might increase. And then another bad news is that, yeah, 2 of them would pose risk, so we could have problems because of the exposure to these two contaminants and precisely epoxy carbamazepine, so the transformation product was the one that had higher hazard quotient. So we really need to pay attention to the transformation products. Going to the general discussion, this is shorter than the papers. I compared the two technologies, so thinking about this decentralized treatment, thinking about greywater treatment, I checked some properties and I compared. So the two technologies are super versatile because they can adapt to different volumes of greywater. They can be set, like they are modular configurations, so we can put them vertical, horizontal, like in many ways. But forward osmosis requires less spatial footprint and lower operation time. But on the other hand, the maintenance cost of hydroponics are lower, and also they require specialized personnel, like we don't need someone that much specialized because at the end there are systems with plants, no? Regarding the treatment performance, yeah, we obtain much more better effluent from forward osmosis, but if we look at the reuse legislation, both effluents could be reused. Then hydroponic systems or nature-based solutions have pollutant removal. So even if the effluent was not that good, but some of the pollutants either got retained in the substrate or transformed in the plants or in the roots, so some pollutants disappear, let's say. And also, with hydroponics, we don't need concentrate management that we have in forward osmosis. We have to do something with the concentrated feed solution. And also, from hydroponics, we have co-benefits. In general, nature-based solutions, they don't have maybe that good effluent quality. This can be improved, but also they produce co-benefits. So apart from obtaining food that is a direct benefit, there are like regular islands for thermal isolation, fostering biodiversity, and other things. So they are very good systems and more sustainable. The main limitations that I identified in forward osmosis during this thesis was, again, these reverse fluxes, and that at the end culminate in lowering the water fluxes and losing the fertilizers, but also some issues regarding the energy efficiency, the concentration polarization, and the fouling should be further studied. In order to improve these fluxes, we need maybe other process setups, but more selective membranes, and maybe working with divalent ions. Maybe that would be the solution. Going to the hydroponics, the main limitation was the low removal of some of the pollutants. In this case, I think that we, in a simpler way, we could increase the absorption capacity of the system, and this removal would increase, also including larger plants. And about the larger footprint requirements, I imagine a world where the buildings are all surrounded by green walls, so we could put them there or in the roof. So that could be solved. And yeah, we have to look at these concerns of regarding the salinity and the food safety. Where or how can we apply these systems in touristic accommodation in hotels? So I propose you two options. The first one would be treating the settled greywater and filtered with forward osmosis, with the fertilizer drowned forward osmosis. And then after nutrient adjustment, we could apply this diluted raw solution to water the plants that we have in our hotel or in our house or in our school, and then we can eat them. With the concentrate, what I thought that we could treat it like we could add algae, which is also like more sustainable way. And then this algae, we can take up these reversal fluxes and treat it, and then maybe we can reuse it or do something with the algae. Then the other approach is mainly nature-based solution-based. So because of the results that I obtained, that including directly the water in for the food crops would not be safe. I think the water could be treated first in a more mature nature-based solution, for example, a constructed wetland or a green roof, with bigger plants, with more substrate, and then we would need disinfection. In this case, I don't recommend chlorine because chlorine is not very good for the plant. So I was thinking something like solar-powered disinfection, maybe UV, solar-powered or something. And then after nutrient adjustment, we arrive at the same point. Within this approach, it would be much safer to eat these plants because the water is already treated before. But yeah, so why this is not installed everywhere, at least the greywater separation? Well, I identified some barriers. The first one was the installation of these systems. We need dual piping systems. Of course, I think that for new buildings and this legislation, they exist in some cities, it's already mandatory to include this separation of the greywater. But yeah, we need space, we need regular inspection and monitoring and specialized personnel. I think that for hotels it would be a little easier because, as I saw in the paper, most hotels have swimming pool, so they must have someone that knows already about water treatment. Then the financial constraints, okay, incentives or cheaper things. I don't think there are other ideas. About the public perception, while water reuse is mainly accepted, everyone or most of the people think it's very nice, then it's not that clear that people want to have to do it themselves, like having the storage tank in their basement. So we really need to educate, to show the people how important is it and how safe can it be. And then something that really makes it difficult is the complexity and all the bureaucracy that are required and the legislation gaps. So there are no organic micropollutants in most legislations, and the risk assessment also is not that much included. And I found some gaps in the legislation because there are not or almost not a specific legislation for greywater. So maybe some people don't even think about it. And actually, the effluent of the hydroponic system, we saw that only the effluent from greywater end would comply with the European reuse legislation, which is focused on agricultural reuse. That's it. It's very nice because agricultural takes a lot of water, but this is the only scenarios that we could apply. But if we look at the Spanish legislation, we have much more scenarios. This legislation is much older and now is under consultation, so maybe it will get more strict, but by now we could use both effluents for different scenarios. So I think this opens really the opportunities for reusing the water, and even they leave like one other environmental uses that we could think about. So if the tribunal allows me to read the conclusions, shall I or not? Shall I? Okay, it's only one slide. We are now finishing. So yeah, from the beginning, from the first paper, I identified the need, but also the big gap for improvement regarding this water management practice in European, or in general in hotels, I would say, and also everywhere. Then the fertilizer drum forward osmosis approach is advantageous. It's a very nice idea, but we need to overcome these challenges because we cannot use the technology as for example, I tested in osmotic equilibrium. Then about the efficiency of forward osmosis for greywater treatment, it was very good in general, excluding these monovalent ions, but we have to pay attention to this air rejection decreasing with the time, with the recirculation time. We obtain satisfactory performance of these hydroponic systems to integrate the crop production and the water treatment. But yeah, if we look at the organic micropollutants, there are risks and concerns that we really have to further evaluate. About the recovered magnesium phosphate products, they were successfully applied. So I think that from now on, we should only use this if possible. Then, yeah, we can integrate different systems. In my case, I was working with nature-based solutions or for water osmosis to increase the efficiency of the process and increase circularity. But we need to overcome some barriers for the installation of these systems. So finally, I believe that all efforts should be directed to go to this circular economy paradigm, to reuse as much as we can, and to include edible gardens whenever we can, to also include, increase food safety and advance in sustainable development. So yeah, that was all. I want to thank you, to thank ICRA and University of Girona, where I did most part of my research, but also in Rai in France, where I did my research stay. Also Agaur, which is the agency that, where I received the scholarship, and some of us that we can research with a little bit of money to live, so that's super nice. And then the 4 projects I was part with, and yeah, all the entities that make this possible. And then I selected some of very, very nice moments that I got to live with all of you. And yeah, muchísimas gracias a toda la gente porque habéis venido y por estar siempre. And yeah, I mean, there are much people, but thank you so much. And the final thanks go to my 3 supervisors. Like, thank you, first of all, for supervising the 3 of you. And then thank you for being so patient, so supportive, for giving me so many opportunities. I participated in a lot of congress, in a lot of activities. I did much more than writing 5 papers. And yeah, thank you for always believing in me. It was very nice. So yeah, that was all. Ah, bueno, claro, yo de pie y vosotros ahí. Vale, vale. Sí, sí, claro.
Necesitarás la...
Ah, bueno, a lo mejor tengo que mirar. Bueno, ya me lo dices. Ah, mira, de Tarragona ahora.
Esther, ¿quieres ir al lavabo o algo? No. Do you want to go to the toilet? Okay, now lots of people will leave now. They were
Gracias.
listening to her, but still. Líder, very nice picture, ¿eh? Muy bonita la foto de las lechugas.
Ella es la creadora
Yeah, please. I want
más
to
de
do that.
dibujos,
Thank you.
por eso. But you are not... Ah, ok. ¿Cómo se va todo el mundo?
Well, yeah, thanks, Esther, for your presentation. You made the final speeches before the official questions, so you have to keep something to celebrate after that, so because you will have to talk.
I can do more.
Okay. Yeah, and thanks everybody for the attention. So now, as I said before, we have like a few minutes or hours for the discussion. So I think that Daria, you will be the first. In general, we just make one round, but if it's enough, if you can interrupt while we are making questions, you can talk at any time. But if not, we can do it like following this order. So take your time for your comments and questions to Esther.
And also, if one of you wants to add a comment, you're welcome to.
We will. Thank you.
Okay.
No, this is too much, I think, no? Or what do you think? Or do you need that much light? Maybe like this, yeah.
Thank you so much for so nice presentation. I think you managed to put in all the results actually in 1 hour. I mean, it was a lot of work, but you went through all of it very nicely. So I enjoyed it. As well as the topic itself, because I'm also working with closing the cycles, and closing the greywater cycle is very appealing, of course, and seeing a new approach, a new type of treatment train of how we can close the greywater is, of course, of a high interest. And the systems that are now existing for greywater recycling are actually aiming more or less to use the treated water for toilet flushing, and with this coupling with hydroponics, you are actually adding the value to the grey water with food production, which I think is really nice to couple the sanitation and food production. But of course, there are concerns, as you explained, and you worked a lot with organic micropollutants. And here I would like to hear a bit more from you. If we look into these different fractions of domestic wastewater and micropollutants, in which fraction do we expect the most? How much? Which type of?
Well, we would expect the most in the, if we're talking about domestic wastewater, in the black water, of course, but then if we go to the under, I think we can see all pharmaceuticals, yeah, more things that we eat, let's say. But for example, for the light gray water, that is the water that is in the, yeah, from the showers, we also see some compounds that are present in like creams, for example, some endocrine disruptors, some in like triclosan, I think like is for, I think it's for insects, no? And yeah, so apart from some pharmaceuticals that we can get from the light gray water, we can get these plasticizers and these compounds from from shampoos and all of these things. And I guess that for kitchen wastewater, gray water, we might find maybe pesticides when we wash the fruits, for example. Yeah.
Pharmaceuticals, they are coming mainly from?
It depends. I would say that from the light gray water from the toilets, because yeah, is where we wash our teeth. So when we spit is where we could find, and also yeah, with real water we saw that people also pee in the showers. So this is something that
the source then of the pharmaceutical.
Yeah.
But yeah, okay, so. The cleansing stuff and so on, they are bringing also the surfactants and so on.
Yeah. Exactly.
But what about these concentrations? So pharmaceuticals in black water, what range do you expect in black water?
Black water, I think it's a very big range, and I don't know exactly the value, but I think they can reach up to like 100 micrograms, but I'm not
But the
sure about
surfactants
it.
would be in what?
The surfactants, for example, in the light gray water can go up to 500, or maybe they can reach milligrams. But in my case, for my synthetic light gray water recipe, it was the highest, I think it was 300 milligrams, actually. Sorry. Yeah. The micropollutants are in the micrograms range, but sorry, yeah, the sodium and everything, it was milligrams, yeah. Yeah,
the
I got a little. Yeah. Like pharmaceuticals, they can be found up to 100 micrograms, but it's very weird. They are usually maybe 1 microgram or something like that. Yeah.
So it's actually lower that you had in your experience.
Some of them, out of the 20 micrograms, out of the 20 micropollutants, only like 4 or something like that. I check with some grey water sources, so they can be much higher. For example, ibuprofen, you can find it like 100, but not others, like not that typical pharmaceuticals. Yeah.
How would you proceed now if you would have an extension of the project or something? Continue with this research? Would you adjust this cocktail, or would you continue with focusing on pharmaceuticals, or do you expect that focusing more on preservatives, filters?
I'm interested in the endocrine disruptors, so it's a pity that I couldn't include more, but I think, this should be really also considered, because it's not only the pollutant, but it also can affect you, and they are not maybe that much studied as the pharmaceuticals, so I would like to include maybe some hormones and, yeah. Yeah. Because they are also present in this Greywater. So yeah, but I would keep also the pharmaceuticals. Maybe I would include, if I could, some more antibiotics because of this antibiotic resistance. So it's something more to study. Yeah.
And if we stay with the Greywater, what I miss generally in research done in Greywater is one parameter that is a bit neglected compared to, real Greywater that you get from a house or a hotel. And I think it's getting maybe not enough attention.
No, I don't know which parameter, sorry. I don't know.
It's not a chemical, but it's a physical parameter. What kind of water do you use when you take a shower or when you have a dishwasher or washing machine?
Because of the soaps, the hardness or something like that, you mean?
Like if you wash white towels, for example?
The fibers or this, or I don't.
No, I think it's the temperature. So what's the
The temperature, okay. Yeah, sorry. I was thinking about something like, some pollutant. The temperature where I have some experience in sampling Greywater from showers, and it was a little hot, but what I think is that the Greywater would be settled in a tank before applying to the hydroponic, so with this it will cool down, and then we won't put like 38 degrees water into the hydroponics. No, it will be pre-settled, and then it will get like a room temperature,
Or even maybe take advantage of this heat and recuperate it to heat, maybe.
Yeah, that could be. I don't know how, but yeah.
It's also done in some real cases of recycling.
Okay.
They recuperate the heat from the warm Greywater to heat the sanitary water.
Yeah, and then they can.
But how can this affect the processes? Maybe in forward osmosis, the temperature also?
Yes, the temperature induces more diffusion, so yeah, I would work more in room temperature also, because if you want to keep, you don't always have the same temperature of Greywater, because you can shower with hotter water, but then you will wash your hands with cold water, so it's not homogeneous. So I don't think it's good for live systems, but also for forward osmosis. So I wouldn't include like this factor. I would wait it to cool down.
Down to the
Yeah, but I didn't think about the temperature. But yeah. Come on. No, from the washing machine, the water is you see, like it can really vary a lot.
Also for hydroponics,
You
also notice that the temperature range is quite narrow, and you have to keep it.
I wouldn't put 40 degrees in the poor lettuces. Come on already.
More than this 25 can show some.
Yeah.
Okay, and then decentralized systems. So you suggest those type of solutions for decentralized systems. Can you just list some advantages of decentralized systems compared to centralized ones, and if you can think in relation with organic micropollutants, how could this affect the concentration?
Decentralized systems, if we have the space, they are more, for some things are more efficient because you treat it and then you reuse it. So I'm thinking maybe not in a house size, but maybe neighborhood, schools, hotels. So you treat your water, you avoid the pipes, everything that you need to go to this centralized system, you avoid it, and you can already reuse it on site. So that's very efficient. Regarding the organic micropollutants, we would have to consider the use, because on the one hand, if we keep the same organic micropollutants within the same cycle, it's not that much diluted maybe as in the municipal water, but also, for example, the tourism has this input of water and micropollutants to the municipal water, and it's really fluctuating because there is a lot in summer and not in winter. So if we could reuse, we would have a more stable, like centralized system, because it's always needed or now needed. So yeah, that would be one of the main, I think, the main advantage. And then, yeah, for the economics, it would really, I think, depend on the technology. Because if it's a constructed wetlands, it's pretty cheap, but if we go to membranes and other things, it's more efficient in a bigger plant, yeah. But, yeah. But also, decentralized systems are also good ideas, not only in urban environments or in hotels, as I proposed you, but if you have a farm, you have a masia, which is the typical house here in Catalonia, in the middle of nowhere, it's a very good solution, yeah. Because you don't have access to that.
You have another factor that is actually quite important for the quality of greywater.
Yeah, yeah,
this is
yeah.
like the people really see their closed cycle,
Yeah,
and
exactly.
they will pay more attention to what they wash down the drain. Right?
That's, yeah, you know the water that you have because you produce it, so yeah.
So
It's like your reclaimed greywater and you made it, yeah.
So I think this is also one of important advantages of decentralized systems, that the people are more engaged into the water cycle, and then we can actually better control the source of pollutants that are coming into the cycle.
Yeah.
Okay, you had some problems with salinity in hydroponics. Do you have any idea?
Yes, I could address the salinity well. If you cannot face your enemy, so I would put more salinity tolerant plants, or I would try to dilute the greywater. So I am thinking, although here is not that stable, but I think we should also collect that rainwater or water from the air conditioners. Maybe it's not a lot, it depends on the setup, but I would maybe, regarding the use, mix all of these impaired sources that will reduce the salinity. And yeah, exactly. So yeah, this is what I would do, and put more tolerant plants. Yeah, we use lettuces because it's like the more sensitive and blah, 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 but yeah, I would go for others. Although they weren't that much affected, but yeah, it's an issue of concern. And also regarding the salinity, I believe that we need to use hydroponics. It's better to use hydroponics, because if you add this water with sodium into the soil, at the end you will have some problems. So also hydroponics are very good because they are closed and then they don't contaminate. Yeah, exactly. Yeah.
And the hotels, the first study, it was also really interesting, and I suppose a bit disappointed at the beginning because the responses were.
Yeah, but well.
On the other hand, you had a nice group of countries.
Yeah,
But this would make me think that already the people that responded to the questionnaire were the ones that were somehow interested in the work.
Maybe. Yeah.
Of reuse that already exists would be
Yeah.
But then another data that was also very interesting to me was the 60% of answers that didn't have water to be wastewater.
Yeah, there was, the response rate was low, and even in many questionnaires, some people, they answer like, the first 10 questions or whatever, and then
Then
ciao.
they stopped. Okay.
So yeah, the thing is that there is also a question about, I didn't talk about it, about environmental awareness, and yeah, of course, most of them, they say they are environmentally aware, but then they don't have like 10 minutes to that. So this is also discussed, like it's like to project, I believe that some are environmentally aware, but also to project this green image. So maybe it's like, okay, let's check this questionnaire, but then when they realize it's longer, they are not that interested. So yeah, it's a pity. It's a pity, but at least it includes many countries. It was done in different languages. It was not only in English, it was only in Slovenian, for example. So yeah, I hope the answer was higher, but yeah, well, 80 hotels from 12 countries, I think is somehow we can get an idea, yeah.
Compared to other studies, it was still
Yeah, it's still a lot, yeah, indeed.
And there was also one thing that I think would be good to add to these questions, because, you know, what would be the main driving force for the hotels to decide to go for water recycling? What would be the first thing?
At the end of everything, I think it's the regulation, because all of the, I mean, we can have the idea of getting more green and blah, 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 but then if we are not obliged to do that, usually people maybe don't do it, they don't invest, or... So I think that that's the problem. Like, I hope everyone had more green mind, but I think they should be more normative.
Of course, the regulation, because if it sets the straightforward demands, then they will have to do it. But another thing is that might also be the trigger for the hotel to start with reduces money.
Yeah.
So when something is really beneficial for the budget of the hotel, they will do it.
Yeah, but in this case, the problem is that water is very cheap. So the issue is that, the payoff of these systems, okay, maybe in 10 years you have it, but you need those 10 years. But there is an example that we live in Catalonia this spring. Now it rained, but there was a point that it was like totally drought. And actually they said, okay, for summer, filling up the swimming pools is forbidden in the hotels. So the hotels of a particular place here, Lloret de Mar, some of them, they bought, I don't know how is the story now, but they bought a desalination plant, like they had to spend 1 million euros or something like that, because they said, okay, can we get the water from the sea? Yes, but you cannot use drinking water for the swimming pool. So imagine, now they have invested that. So at the end, the problem is that, water is too cheap. I mean, I totally agree that water should be cheaper, but yeah. Sometimes I think that they should put like very cheap prices until some volume and then increase it a lot. That's another thing that I think it could work. Yeah.
Yes. Thank you.
Thank you.
Further questions.
Thank you, Daria. And then now, Julie, it's your turn.
Okay. Thank you, Esther. It was I'm very pleased to be here. I know about this lab for a long time, and I really believe in the combination, the coupling of membrane filtration and nature-based solution. So, and I learned a lot of things reading your manuscript. I bother you a lot about energetic aspects, and I like the answers that you gave and the paragraphs that you add in your manuscript. So, if I understand well, the specific energy of forward osmosis is quite low.
Yes.
And it increases because of the draw solution recovery.
That's continue. Sorry.
Yeah. So, and you don't have this problem, but you have the problem of the concentrate. I don't understand what you propose to treat the concentrate. You had the slide at the end.
Yeah, at the end.
So, can you explain?
Yeah, so about the energy, this is what I found, so it's not really clear, because in some studies it's like, if you use this before RO, before reverse osmosis, then you lower the osmotic pressure, so then the hydraulic pressure would be lower, but it's not clear how efficient is that. But what is clear that it's the fertilizer done forward osmosis is more energetically efficient. What I propose with the concentrate, for me, out of the options that I saw, is to add algae, microalgae. I saw like 2 or 3 studies. So because we have this reversal flux of nitrate and phosphate, not phosphate.
But you have also a lot of micropollutants in this concentrate.
Yeah, but also algae can treat so they can be used as a treatment, because maybe some bacteria would be more sensitive to salinity, but not the algae, as far as I know. So that's why I propose that idea, to treat the concentrate with the algae.
So it won't raise the energetic consumption of the whole process. Slow consumption. What do you think?
It will, but I don't know, like we have to do something with the feed solution. So
Yeah, but
another idea,
it's
for
not
example,
like
is
a
an
thermal
anaerobic.
treatment, or
No,
it seems to be
yeah,
quite
it's
low.
just like a pond with algae, so it would be the least, maybe it will need more time, but this is what I thought. Another idea was the anaerobic digestion, but this is...
Because if you can
story.
stay around your 0.2, 0.5 kilowatt per cubic meter, it's
That's good,
very
no?
competitive with
Yeah.
other processes.
The problem is the fluxes, but
Yeah,
okay.
I understand. So let's switch to my next question about the fluxes.
Okay.
So you say several times in the manuscript that we have to improve the material. So what is needed? What?
I don't know, but
Characteristics.
we need more selective membranes. There are many different materials, and I saw that there are some membranes that are even made with like the shells, as I told you yesterday, the shells of the shrimps and these kind of things. I don't know if they perform better or not. I read some papers with other new materials, and they say, yeah, we have very high water fluxes, very low solute fluxes, but yeah.
But something about hydrophobicity, or no?
I think it's more related with this movement of monovalent ions, because the rest of the compounds they don't pass through the membrane. So I don't know.
A charge surface treatment, or
Maybe the active layer treatment should be different, but I'm not into materials, so I don't know.
Okay.
Also, this putting these aquaporin proteins is which they are apparently 100% selective to water, increases water fluxes, but then after dilution we saw that they decline. So this is like something like more new, let's say. But yeah, I don't know which material would I coat the membrane, but maybe with, yeah, and somehow decrease the porous surface, or because, yeah, this happens.
And
But
I'm not familiar with forward osmosis, but can we talk about molecular weight cutoff for this membrane? And what is, if yes, what is a molecular weight cutoff?
Is an idea of the porous distribution size, but it's not at the end, when I said also the molecular weight is not exactly the molecular weight, because the compounds are hydrated, so it's not only, you know, it's an atom. So it's an idea of the porous size of the membrane, and it's called
But if you know
weight.
only the molecular weight of the compounds, you cannot say that it will be retained or not.
Yes, also we have the
Oh,
porous
it
size
is
of the
very big.
membrane. Yeah.
Yeah.
Also there are like in some studies you see what is the porous size of the molecular weight cutoff. Is like, they say one thing or another. And I think the molecular weight cutoff, it like embraces like more, but yeah, you can, in some studies they compare, like this is the hydrated size and this is the porous size.
Okay.
Yeah, but I don't recall mine. I mean, I have it in the papers, but I don't know.
And your micropollutants, they were well retained by the membrane, but
Yes.
it depends on the matrix. Can we come on the slide, or
Yeah.
you can, or
Yeah, of course.
30, I think.
This one or the one with all of them?
With all of them and the matrix. Here.
This one, no?
Okay, so it really depends on the.
I mean, the rejection is very similar, but whenever we have grey water, the rejection decreased a little bit. And also with fertilizers,
Yes.
in some occasions, it was decreasing for some of the pollutants.
How do you explain the difference between
Between grey water and the ionized water?
for a molecule, because between this one?
I don't know what you mean. What the difference do you want me to tell you? Okay, yeah, because when we have the...
Which mechanism?
Yes, because when we have the salts in the opposite side of the membrane, we have an induced flux movement of the micropollutants from one side to the other, and also because the experiments of this, they lasted 14 hours, and the ones with the ionized water, they lasted 7 hours. So we have, for 14 hours, salts in the membrane going there, so at the end they can experience this retard diffusion because there's like more recirculation, so they can get retained and then pass to the membrane. So when we had the grey water in general for most of the pollutants, you see that the rejection, even if it's very high, it decreased. Yeah.
Okay.
And it's but these mechanisms, this diffusion favored by the salts and the
Okay.
contact time. This is what I believe. Yeah.
And in your manuscript, there is a result where the micropollutants are better retained in deionized water
Yes.
than in grey water.
Yeah.
I was surprised by that.
Yeah. I think it's because of that.
Yeah.
Because the grey water induce
Okay.
the salts in the grey water induce the
Yeah.
movement and the contact time.
Okay.
But it's I don't know at the same time if it would be, because this is the rejection at the end.
Yeah.
So this is 6 hours
Yeah.
and this is 14. So maybe after 6 hours it would be the same rejection. I don't know. But also I was checking at the dilution of the draw solution. So
Okay.
yeah, I cannot compare like exactly the same conditions. So I decided to compare with
Okay.
time and not with the dilution.
Okay, I understand.
I mean, with the dilution and not with the time. Yeah.
Regarding the first paper, it's very original. Was it your idea or the one of your supervisor?
Well,
Oh,
it was it was a previous idea, and I processed all the data and I wrote the paper. Yeah.
Okay.
Yeah.
But when you saw the length of the survey, don't you think it was dissuasive? Because when I said, "Oh, it's complicated to answer all these questions," maybe if you have shortened.
Yeah, maybe a shortened questionnaire would be easier, but I mean more attractive. But maybe not at the end.
I think they receive it and say, "Oh,
Yeah, 70 questions.
Yeah.
But really, it's very, if you look at the questions, I know it's 70 questions, but many of them are yes, no, or just like select the saving devices, for example. So it's not that you have to write what you do in your hotels. It's like you have this, yes or not. So
Yeah, but I
it
think
could be
it's
answered easier, but maybe reducing it a little bit would
you
be.
could have a better response rate with a
With lower,
shorter.
no?
Yes,
Yeah.
I think. But
Yeah.
and you say you gave the composition of grey water, the average, but without the level of pathogen,
Yeah.
despite the fact that you say it's a big problem. So
Yeah, in my case, the recipe also included a secondary effluent, but I didn't include it because I was more focused on the like physical, chemical properties, and yeah, also in real applications with some bacteria, maybe we would experience some removal.
but what is the level in real grey water of pathogen? Are we far from the regulation?
This is really variable. We have, I think, lower species, but it also, it can be diverse, and they can reach, usually the level of pathogens is lower, but they can reach the same level. So it really depends.
Okay.
Of the total.
It depends on what.
On how people or what do they do in the house. I don't
Okay, I
know.
don't want
Like
to
if
know.
what do you wash in the kitchen? Where did you harvest it? What do you throw through
Okay.
what do you do in the shower? I don't know.
Yeah.
This is what I think.
I got it.
I don't know. This is what I think. I don't know.
Okay.
It should be lower, but it is. I've analyzed real grey water, and there was E. coli, and so.
Okay.
Yeah.
And you say in the manuscript, and I agree with you, that the number of parameters in the regulation should be increased concerning micropollutants, for instance. But don't you think it could prevent some project from going ahead?
Yeah, it's tricky, this thing, because we really have to pay attention to the safety, but also, if we put sorry, I got a little distracted. Okay, if we put more parameters, we are more strict, so then we would reach more safe scenarios. But also the problem with that is that analyzing organic micropollutants is pretty expensive. So I think things would be cheaper, or maybe get some detection methods that are not like mass spectrometry. But this is and I've been in some like congresses. I recall there's this one man from Murcia in Spain that was precisely saying that, like, yeah, now these are getting more strict. They are including more, because, well, in France you have this Clostridium, like more also
Yes, more
pathogenics.
microbial.
But then he was like, yeah, but so for that, I think maybe we have to elaborate, like more elaborate a risk assessment to assess that, and also, yeah, cheaper methods, and yeah, but I mean, if the organic micropollutants are not included or other parameters, yeah, at least I think we need to know the risks.
Okay.
But yeah, I totally agree, yeah.
You describe adsorption in hydroponics concerning micropollutants,
Yeah.
but can release happen?
Yes.
Yes?
Yes, yes,
Okay.
yes. I didn't do it, but yeah, they experienced retarded diffusion, and actually there is a study from a girl that I know from the center of Spain that she tested the same membrane as me, and then she was washing the membrane and collecting the milieu. I think she was, or deionized, so to have and then, yeah, she managed to recover almost all of that was adsorbed, not everything, but yeah, she managed. So yeah, she saw the desorption. So I know this can happen, but I didn't test it myself.
But in your in hydroponic also, in your
And in hydroponics,
okay,
yeah,
yeah,
as well,
okay.
yeah. Yeah, when we have a concentration different of the water, then they can
equilibrium
resolve.
can be modified.
Yeah, exactly.
Yes.
Yeah.
Nothing to see, but in hotels where there is greywater reuse, do they communicate about it? With panels or poster or?
Well, because I started doing my PhD actually within a hotel that they do greywater reuse, but then COVID came, so that's why I'm using synthetic greywater. And in that hotel, yeah, they have like a banner that they were part of this project, and in the website, they have it. I only know this example, but also the ones that answer, there are 3, so I guess they should have it, yeah, because also this greening image also attracts clients, so they should.
Yes, but
I just know this one example.
You conclude saying that it's important to educate people, communicate. Have you ideas to communicate to the general public about your work and what you are doing?
Well, I think, for example, my friends that are here, yeah, I've told them about some things. So I haven't done many things like presentations, but yeah, I tried. I would like to disseminate a little bit more, because I've been in more congresses, but these kind of activities I've been part, but not that many to the general public, and I think they are very important.
Because you have 5 articles, it's very, very good. I don't know if in France it's very good for a PhD, but it's here too. But regarding the issue, you can also disseminate more.
And also, now that I think about, also is in the beginning of the thesis, I wrote like another like 3 little articles. One of them is a book chapter, but there is another that is more like for the general public, but it was published in like more technical water magazine, so it was still technical, but it was not like scientific, let's say. So I did a little bit, but yeah, I should do more. I would like to. Yeah,
okay.
Indeed.
I would like to finish with congratulations, because
you
have a quality, didactic quality, I think, pedagogic. Yes, it was very nice, and the illustration, and you did a very good work, huge work, multidisciplinary. So, congratulations, Esther.
Thank you.
Okay, thanks, Julie. So it's my turn. Esther, are you tired? Do you still have energy for more questions?
Yes.
I know that.
Lot, but
well, you're almost there, so don't worry. Well, first, I will join in the congratulations of my colleagues. We told you before, but have very good indicators, lots of papers. The report is very good. The presentation was fantastic. Your answers are also very good. And I know that I was not involved in these projects with you. I knew a little bit about them. But you don't know that I attended all your virtual meetings, because Kim is at my office at the University of Girona. So
well, sometimes I've seen you behind, yeah.
So I could follow when you were worried for your stay, for the papers, and really, no, so...
All the dramas, Ignacy, there are a lot, eh?
Also, I didn't want to mention that, but... So I could follow, and you really work really hard, and you were motivated, so fantastic in that sense. But we have to make some questions. So I'm lucky that my colleagues made most of them, but I still have a few quite general questions, I think. And the first is just from the very beginning of your thesis, it's like if you assume that circular economy is the future, is a key, it must be like that. And don't worry. It's but some people in our field, they don't agree. So circular economy as a concept is interesting, of course, but if you force it a little bit, sometimes you spend more resources trying to recover like everything. So in water, it's not that clear. And then the second part that you mentioned is that also, again, like if decentralized systems is the future, I agree with that, but it's not that clear. So when you go to decentralized, so the first is, if you can tell me what's your view for the future for water management in the cities or in the world, and if you follow these two paradigms of decentralization and circular economy, and then maybe I will make you some specific questions about that.
Okay. So yeah, regarding circular economy, yeah, I think we have to go circular. I don't know, but yeah, regarding, for example, the recovery of phosphate. I don't know if it's energy efficient or not. It might be, it might not be, but there are not a lot of phosphate, so we have to do something. For other things, maybe, yeah, we need to get more energy efficient processes, or maybe, yeah, we have to look for other options, but there are some materials that we really need, so we have to do something with there. About the future, well, I saw one of my ideas was like walking in the city and see all green around. That would be super nice. But about the centralization and decentralization, yeah, I agree. So now we have the cities and villages with this infrastructure of all the pipes and everything. So maybe in some scenarios, we have more centralized systems, but this very big wastewater treatment plant, maybe in some ways are more economically efficient, but I think they are like maybe too big. So I think a combination within these two would be the, yeah. I don't know what is the ratio or how could it be, but yeah, in some scenarios, decentralization is better, like if you are in the middle of nowhere, or maybe for this one specific hotel, but maybe in a village like mine, that we are 3,000 inhabitants with one treatment plant, maybe is enough. And you don't have like everything in your house, so it depends on that.
Okay, thank you. Don't worry, because there's not a right answer. At the end, it's like an opinion. You're an expert in the water field. When you talk about decentralization, are you assuming a small facility, as you mentioned, in your village, or are you thinking about source separation, as you made here? So try to avoid this integration of different streams with different qualities and this dilution before treatment. Which one do you think is better? And maybe to add some complexity, is this a solution that you think for the future worldwide, or you are thinking about these Mediterranean countries where we have water scarcity? So you see, like they will do the same in the States, in Catalonia and in Senegal, or?
Well, about the separation of streams, I think, yeah, if we consider in the designs of the buildings, I think is much better if we produce enough volume, because then the treatment is different. Like if we have a more polluted stream, we need a more complex treatment, and maybe other reuse applications, they can be different. So I think that segregating, it's better for like safety and treatment concerns. And then the application, of course, there are some areas that face water scarcity more than others. So we should focus more on these areas. But at the end, we are also dealing with water quality. So if you know the water that you are producing or you are treating again, and maybe it's not only for water scarcity, but also for water quality, because there are some very, very polluted streams or rivers, so maybe once you have this treated and you keep it within the same cycle, the safety concerns will lower, maybe, than if it depends on the scenario.
Okay, well, that's a little bit the idea. So it's quite flexible. There
Yeah.
are different solutions.
Yeah.
You try one of, I also like these hybrid approaches. So
Yeah.
it's like, no, must be green, must be gray and compact and sure and safe. At the end, it depends on the stream and the necessity. So we could discuss a lot about that, but I leave it here. My second question is about, and Daria asked you a lot about that, but about the organic micropollutants. I recognize that I was also surprised when I saw that list in Greywater. You explained it in the thesis. You replied that we use the creams and everything. So, but my question is, did you make that list from the literature? Did you make any measure of real Greywater? Even there was COVID, you said at the beginning, but did you analyze to know that those compounds and those concentrations are representative, or it was from the literature? That's the first question of the...
Well, it was from the literature, but from real greywater sources. And yeah,
Literature from Greywater.
the real greywater that I sampled was not analyzed, but the previous papers about the same place, yeah, there was this list. So then, with I have to match the capacity of the methods that we have, because I didn't develop any method for analysis, with what I found in literature, and then I was choosing, like, if I have the same molecular weight, so different charges, or blah, blah, blah. So we said, yeah, mix around 20, 30, and this is what we got. Okay. And about the concentration, I choose the lowest concentration that I could do with the capacity of the system. Yeah.
But if you have problems at the Catalan Institute for Water Research to measure that, imagine in a house in your village.
Yeah,
but
yeah,
then,
yeah, that's why.
No, then yeah. What I thought is that, because I'm used to see percentage of removal in wastewater, and I thought that maybe in Greywater for some specific compounds like the cream that you mentioned, concentration will be higher, because if that goes to a standard stream, it's really, really diluted, so maybe you can not even find it. So maybe this 95, 99% of removal is not enough. I know that you compare with legislation and everything, but nothing is really prepared for that, no? So, yeah. So maybe in this case, you have to reach higher removal rates when you separate the streams. That's why I was asking you the concentrations.
The higher the better, of course, but yeah, also it's the typical removal that you would get somehow, unless, yeah, with a more great technology, you would achieve much higher of BOD, but it was very high. So, I mean, yes, the higher the better. But yeah, it depends on the technology and the characteristics of the water, because there are some recalcitrant compounds maybe that can decrease the removal. Of if the salinity is higher, and we look at the removal also with bacteria, we would have maybe more concerns than if we have lower salinity, for example.
Well, yeah, okay, so I basically wanted to point out that maybe 95 is not enough if the concentration is higher, and with some compounds that you do not expect. And then you talk a lot about risk, no? So at the end, yeah, it's a health risk, no?
Yes.
So why should we, I mean, there are no easier alternatives than trying to produce food. I know that you wanted to add, because it's one of the criteria when you chose the technology. No, I know I can treat Greywater, but I want to produce food at the same time. But then, yeah, arises all this health problem that we cannot have like a more strict legislation, we cannot control, we cannot measure. Maybe yeah, I mean, the origin of treating wastewater and avoiding water reuse, it was because of pathogens in irrigation. So, yeah. Don't you think that, I mean, it's a fantastic work, but now that you finished, don't you think that it's a better alternative for the hotel in Costa Brava?
Yes, yes, I mean, the water has to be treated before. So I just wanted to test the worst case scenario as a proof of concept, and even with this these concentrations, we reached, I mean, it was risky, but if we look at the individual compounds, only 2 could pose risk, but of course I don't recommend growing edibles in raw Greywater. And even if the main concern was about the exposure to pathogens, and I didn't include pathogens, so it's like, okay, I justify that. But yeah, the legislation, you cannot use directly that Greywater, so you would pre-treat it before. That's why in the when I propose the two options, if I want to go for nature-based solutions, I would put before without edibles, yeah.
I saw it in your discussion. Don't think that I was not paying attention.
Yeah,
you
yeah.
explained that,
Yeah,
and
of
it's
course.
good, no? So,
But
in fact, I liked a lot this final discussion in the thesis because you can go a little farther from what you really studied, and you can give some of the ideas. So that's there. So good. Another question. Now going more to my field, and that will be probably the most strange question that they make you. But you know that your thesis fits very well in this green and digital transition that we are living in the world, but especially in water management, in cities. And you studied a lot this green transition, but you didn't mention anything about digital transition. So now, if you can think a little bit, I told you it was good. No, if you think a little bit, that's at the end, it means that we will have, or we are having, more and more cheap sensors, and we can measure lots of things, and we can control, and we can have a cloud with lots of data. Yeah. Do you think that that's good or bad for your decentralized approach, or for your idea that everybody at home can have like a green wall or a hydroponic with membranes? Does it help? Is this a driver that we have this digital transition?
I think yes, I would say, because I see that usually humans are very attracted by, you know, being able to control and see and blah, blah, blah. So I don't know that much about this digital transition, but I think that the more parameters we can measure, maybe at some point it's like, oh, I cannot reuse this water, but at the end it's good for you, because if it's not safe, so the more data, I think, the better. But yeah, we have to see, because maybe that sometimes is too much. But yeah, it would be super nice that if we have like cheap technology that will tell you, okay, today the conductivity is too high, so we dilute it or we do this. I think it's beneficial.
Yeah, that will help a lot, especially if the price is reduced and that we can see the quality, the amount, everything in our cell phone, whatever. But then my question is, there's like a new chair at the University of Girona, it's about cyber security. Do you think that once we have so many systems, because if we have a central facility, I mean, we can defend, prevent lots of things there, we can have lots of filters. But if everybody at home has systems that anybody can attack just for fun, and they can make you think that the wastewater has good quality, but maybe it doesn't, and you are reusing. So it's a way of, I mean, that's a hot topic too.
But imagine that this happened in a very big plant. Then it affects too much people than if it happens in your house.
Let me imagine.
No, I mean, yeah, of course, this is an issue of concern, and yeah, I guess that more safety measurements should take. I don't know how to deal with this, but yeah, now wastewater treatment plant can get hacked. Imagine, and I don't know. They throw all the... So with very big plants, it would affect more people than if it's in your house. But if they hack all the house, yeah, of course, we are screwed. Yeah.
Fantastic. That's a very good reply of a smart daughter. Because at the end, it's like you have a diversification of places. No? It's like, like alternative water resources in this case. But it's true that the small systems are weaker and more sensitive to attacks, no? So you have to combine at the end. Yeah, exactly. Life is a combination of things. And one last comment, it's about social acceptance. You didn't mention that much in the thesis. It was in the discussion, it was in the presentation. And you explained that exactly the same way that I like it, because it's people at the beginning which just said, no, there's like this yuck factor that people, they don't want to drink regenerated wastewater. And I think that it goes further, and it's what you mentioned, is that people don't want to have a tank in the house, don't want to be controlling chlorination. I mean, we want comfortable things, no? So, yeah, and you mentioned like the solution is education, but for me that's a little bit like trying to persuade the people to think like you think, no? I'm green, my friends are green, if I can talk to the people, they will be green. But why don't you listen to the people? Maybe they don't want to be green. So it's just, if you can add like a couple of comments about that, because I think that that's very important for the future. I mean, all these solutions that we suggest from the university, I'm not sure that the people will feel comfortable, because we don't want problems at home. So it's easy to flash and forget, but then, yeah, try to convince me.
Well, the example that I have to convince you is that now everyone or a lot of people recycle at home. And sometimes it was like, no, I'm not gonna have 5 buckets, it requires a long time. Now in Girona, even we have like specific days to throw specific trash. So, I mean, maybe I can talk about, but it works, but you need the time to do it. And yeah, I think it's necessary. And also when people see that we are in a drought situation, maybe people should see more the problem, but yeah.
It's not that I don't agree with that and education, but sometimes I feel like that we want to impose a way of thinking.
Yes.
And with this,
without listening, maybe sometimes.
well, it's part of the. So we have to work a lot on that for the future. There are other things, but I think that it's more than enough at this point. I don't know if you, Julia and Daria, do you want to ask anything else or a second round of questions or any new comment that arose?
It's just a comment because this was
Yeah, it's an open discussion.
because,
Yeah.
So actually, I think now we somehow live in a period of uncontrolled reuse because water for irrigation of the fields can come from the river, but just a little bit upstream there's a discharge. So we are already, at risk, but it is just not monitored.
Yeah, exactly.
And then we come to the data in the clouds and
Cyber
Yeah,
attacks.
so when, how strict we should be or how, it's all, there are many factors and the economical costs is one of the most and the capacity to analyze, we don't. So I think that, I don't know if there are some sensors that they can measure more like optical, kind of continuous and not taking samples, bringing them, but I don't, we have to elaborate more on this, but we need to reuse the water or more efficient growing crop techniques to grow.
I think that we all agree on that. So
Yeah.
sometimes I have the feeling that you mentioned a couple of times that things are changing, life is dynamic. When there's no water, of course, we need all these complications to save water, but when we have lots of water, when it's raining, maybe it's not necessary.
People
but,
don't think about it.
At the end. But it's not that they don't think about, but it's good that they don't think about that.
Because they don't know,
if we have lots and lots of water, why should we worry so much? At the end, it's a renewable resource. So it's not like phosphorus, as you mentioned. So I have the feeling that there's lots of water, but I'm the only one in this community. So now it's time that you have lots of directors and supervisors. So I think that at least one of them can say something or ask something or explain something related to the thesis. The oldest, maybe.
Yes, we have 3 questions each.
Each.
Only? It's okay.
3 challenging questions. No, it's more about, I don't know, we don't think about that, but we are not going to discover, everyone here knows Esther probably, and you have known her work, so that she's been very, very dedicated. She's perfectionist, I would say, in everything she's doing, but in the lab for sure. And the thing that was surprising me a lot was also she's an excellent planner. She's planning everything ahead in advance very well. Like for example, every meeting she was coming, I remember, always with a PowerPoint with the agenda of all the points that we had to talk, the experiments, the things we had to buy, the conferences, the report, everything. So was and of course, everything about any trip, so well organized always. So that then of course sometimes that's putting a little bit of stress on her.
A slightly little bit, but...
And then, I don't know, that could be a problem with all other people working with her also. I mean, she's very auto-exigent, do you understand that? And
I understand, but
so she's
como es autoexigente, I don't know.
other people working around, and sometimes people are. But she's very good students. And she's an environmental scientist. Maybe you've seen in the CV, but she's been doing a PhD on environmental engineering. But she's been doing as a chemist, analyzing the micropollutants, and also I would say a civil engineer because when you see the hydroponic system, very nice pilot, she designed it and mounted by her.
Yeah, I built it, Yeah, yeah, yeah.
As a summary, I mean, she's been, and she's been a very funny PhD. We have learned a lot. She's been learning a lot for sure. And well, in the end, so she's been one of the best PhDs I had for sure. And then, no, just ahora quizás para acabar, bueno, felicitarte y también
Gracias,
felicitar a la
Kim.
familia, ¿no? A menos que entiendan algo, ¿no? O sea,
Muchas gracias, Kim.
amigos que también lo han sufrido y han dado soporte y esto es muy importante.
Ahora lo repetimos en castellano, ningún problema.
Ahora empiezo otra vez, venga.
Do you want to add anything, Gigi or Gatan?
Just one thing, because at some point you made a mistake during the presentation that you corrected directly. Well, I associate first to the comments of Kim. I was, of course, more involved in the forward osmosis part of everything, but it was a huge work and nice to work with you, and so to learn with the juice and so on of all the things.
Yes.
And no, I just common joke, like you said, when you describe it for osmosis, you said osmosis is the driving force of this project, and then you corrected to process.
Yeah.
I hope osmosis was the driving force also of this project.
Yeah, indeed, indeed.
Behind some chaotic moment, there was also a very nice journey.
Okay, thanks,
It was,
Gatan.
it was.
And Gigi will talk in the lunch, okay? No, it's...
I just wanted to add, of course, that you are hardworking, very precise, but also coming back also to what Ignacio was commenting is that you are a very transparent person and researcher, so it was very good also for us to know most of what you were thinking or what
Yes.
you were feeling, and this is something that also I am learning and I want to learn from you in the future.
Thank you.
Okay,
Thank
thank
you,
Gigi.
Gigi. Thank
So
much.
you said Esther is a good planner. She told me 2 hours is 12 sharp. We have to finish. Now we go, you said that we go to the office and we come back in a few minutes. Thank you. Sí. ¿Está en marcha? Sí. ¿Se oye? Sí.
No tengo que decir yo nada aquí, pero...
We are waiting for the family, yeah, otherwise. So they are the most excited people. They are smoking outside. Never.
Oh no.
¿Qué cosas?
No. Dance, I could, but sing?
Any additional question, Wolfgang, that you arrived? No? That's okay?
Nah.
No problem, no problem. Well, Esther, ladies and gentlemen, after a very brief deliberation, we, the 3 members of the tribunal or the jury, have agreed that your merits are really outstanding, as we told you before. And this conclusion is not only based on the impressive publications, as we said, and all these academic indicators, but also on the exceptional quality of your presentation and defense today. If we had any doubt about your merits, Kim Comas convinced us in your final speech. So what we have decided is to award you with the highest possible grade, with an excellent. Congratulations, Esther, for your brilliant academic career at ICRA, UDG, and France over these past years. Congratulations.
Thank you so much. Gracias. Thank you. Gracias. Yeah. Thanks, everyone. You are amazing people, and it was a pleasure to share my life here with you and continue doing it. So, yeah, muchísimas gracias a todo el mundo y, bueno, pues nada, a celebrarlo.
¿Dónde lo celebramos? Ah, sí, claro. You can kiss the bride.